Okay, so this is section 3 of chapter 8, and we're continuing to look at matrices. You may have learned a little bit about matrices in Algebra 2 or maybe some other math classes, but we're going to look a lot more in depth at matrices. Now we can talk about the dimensions. The word we will use is the order of a matrix, and that's just the number of rows by the number of columns. So for example, we have this matrix right here. We have 2 rows and 3 columns, and so the order of this matrix is going to be a 2 by 3 matrix. And then we can look at specific elements in this matrix. So if we're looking for element A, 2, 3, that would be the second row and the third column, and that would be -1/5. Element A, 1, 2. Sometimes you'll see a comma here. That would be row 1, element 2, so there we go. And if we're talking about two matrices being equal, they have to have the same order, and then they have to have the same elements and in the same place. This should actually be an S right here. Okay. Now we can also add and subtract matrices, but they have to have the same order. So they have to have the same number of rows and the same number of columns. So we can go ahead and do an example here where we're subtracting these matrices. We have 0 minus -2, and that's going to give us 2. And then 5 minus 3 is 2. 3 minus 5 is -2. -2 minus 7 is -9. 6 minus -9 is 15. And -8 minus 6 is -14. So not only do the matrices that we're subtracting have to have the same order, our answer will also have the same order. In this section, we're going through a lot of vocabulary here, so the next thing we're looking at is the additive identity. So it's the matrix that we can add to another matrix, and it won't change it. So that would just be a matrix full of zeros. We can add that matrix to any other matrix. If I have this matrix right here and I filled this one all zeros here, that would give us the same matrix we started with. So that's the additive identity. Now the additive inverse is the matrix that we would add to get the zero matrix. So for example, if I had the matrix -5, 7, and I had 5, -7, that would give me the zero matrix, and those are additive inverses. Okay. These are a lot of properties of matrices. If I add them in the opposite order, then that's the same, or if I have 3, I can add them in any order. If I add the zero matrix or the additive identity matrix, I still get the matrix that I have here, and then inverses equal the additive identity. Those are all properties of real numbers as well that you're familiar with. And then we can also talk about scalar multiplication. Now a scalar is just a number. Okay, so a scalar is just a number, so I can multiply a matrix by a number, and it's just multiplying every element by C. Okay. These are pretty basic things that you're familiar with and kind of work intuitively. Let's go ahead and look at another example here. Here we're being asked to multiply matrix A by 2, multiply matrix B by 3, and subtract, so we're going to go ahead and do that. Multiplying A by 2, I get -2, 6, 8, and 0. And then multiplying by 3 here, I get 6, 15, -18, and -9. And then subtracting, I have -2 minus 6 is -8. 8 minus -9 is going to be 17. 6 minus 15 is -9, and 0 minus -18 is 18. And that's our answer. Okay. So let's go ahead and look at some more properties here. Properties of scalar multiplication. I can multiply A by a number and then another number, or I can multiply those first. I'm not going to go through all of these properties. They're very intuitive. Matrices here work the way we think they would work, the way real numbers work. Let's continue on to another example. if I have matrix A and matrix B, and I want to solve this equation right here, my x value here is going to be a matrix. It's not just a number. Okay. So first thing I'm going to do is solve for x, and then I'll have x equals 1/2 times b minus a. And so I'm going to go ahead and actually just fill that out. X is equal to 1/2. And b minus a. I'm going to do that over here. We have -6, 9, 1, and 5 minus 1, 0, -5, 2. And that'll give me -7, 9, -1, and 10. And then multiplying 1/2 times that, x is going to equal -7/2, 9/2, 10 divided by 2 is 5, and -1/2. And that's our answer. Okay. Now, those things are pretty easy, pretty straightforward, but matrix multiplication can be kind of complicated. If I have some matrix here, matrix A, and I have the order m by n, and then I have matrix B, n by p, that's their order, then matrix A times B is going to have the order mp. That's going to be the order. Okay. Now these two right here have to be the same, and then your order is going to be these. That'll be your order, and then this needs to be the same as that. Okay. So let's go ahead and look at an example, and we'll go through it really slowly. If I have these two matrices here, first I need to check their order. So I have a 2 by 2 and a 2 by 2. These two numbers are the same, so my answer is going to be a 2 by 2 matrix. Okay. So let's go ahead and set this up. And I'm going to set this up for us, and it'll make sense in just a second. So when we're multiplying matrices, we're going across the first row and down the first column for this first element. So this is row 1, column 1. So row 1, column 1. 2 times -10 plus -8 times -9. And then moving on to the next element, we're now in row 2, column 1, so row 2, column 1, and we have 0 times -10 plus 4 times -9. And then looking at the next one, we are in row 1, column 2, so row 1, column 2. So we have 2 times 1 plus -8 times 17. And then row 2, column 2. So row 2, column 2, we have 0 times 1 and 4 times 17. And when we combine all of these things, our matrix multiplication answer, we have 2 times -10 is -20, and then we have 72, so this is going to be 52. And 0 and -36. And then we have 2, and this will give us -134. And 0 and 4 times 17 is going to give us 68. And that's our answer. So those take some practice, and it's really good to organize them. Obviously, I've organized things by color here. Let's go ahead and look at our next example here. We have a 1 by 3 matrix, and then this is a 3 by 1. Now these two numbers have to be the same, and they are, and our answer is going to be a 1 by 1 matrix. So when we multiply these, going across the first row, down the first column, we have 1 times 4 plus 2 times 5 plus 3 times 6. And that's going to give us 4 plus 10 and plus 18 will be 32. So our matrix is actually just one element here. Okay. Now let's move on to some more examples here. We're going to multiply a few more here. And looking at this first one, we have a 2 by 2, and then we have a 2 by 4. These two numbers are the same, and so our answer is going to be a 2 by 4. Okay, so setting up our matrix. Our first element here, I have 4 times 1 going first row, first column. First row, first column. 4 times 1 is 4. 2 times 0 is 0. And then second row, first column. Second row, first column. 1 times 1 is 1. 3 times 0 is 0. Then looking here, we have the first row, second column. First row, second column. 4 times 2 is 8. And then 2 times 2 is 4. And then down here, second row, second column, 1 times 2 is 2, 3 times 2 is 6. Next element, first row, third column, first row, third column, 4 times 3 is 12, and 2 times negative 1 is negative 2. Then down here we have 3 times 1 is 3, and 3 times negative 1 is negative 3. And then back over here, we have back in the first row, last column, so 4 times 4, 16, and then 2 and 6 is 12. And then our last one down here, we have second row, fourth column, second row, fourth column. 1 times 4 is 4, and 3 times 6 is 18. And so it's just a matter of simplifying things here. We have 4 plus 0, we have 4, 1, 12, 8, 10, 0, 28, and 22. And that's our answer. Okay. It takes some practice. It's going to get easier. At first it's a little bit difficult, but it'll get better. Now this next one, let's go ahead and take a look at the dimensions. This is a 2 by 4, and this is a 2 by 2. Now these two numbers are not the same, so what this means is this is undefined, and in other words, there's no product. We can't multiply these. Okay. So that's why it's important to always check the dimensions first. And these are some properties of multiplication. So as long as the order stays the same, we have A, B, C. A, B, C. You can multiply these any way you want. But we noticed up here that if I switch the order of these, so this one went second and this one went first, we don't get the same answer. And in fact, sometimes we're not even able to multiply at all. So it does matter the order that they're set up. So this is first, second, third, and the same here. The same thing goes here. We still have A, B, A, C, A, B, A, C. This is not the same as B, A, and C, A. Okay, so we just need to make sure that the order is in the correct order here. Okay. All right. This one is incorrect. We need to fix this a little bit here. So I'll just go ahead and fix that really quick. And that's the end of 8-3.